Network Dojo.
This video is going to look at basically how does Mobility Express work at sort of an architectural level, how to get this basically set up and running so that you can do all of mostly the normal controller type stuff that you've already seen how to do on the 5508s. So the 1852 series APs in our lab are Mobility Express capable. Now they don't have to be Mobility Express APs, but they can run Mobility Express code. And when an AP is actually running Mobility Express code and it is Mobility Express capable, this means that they can become something called a master AP. And so what's a master AP? This is the AP that runs a virtual wireless LAN controller within it. And so it is both an AP as well as a controller in one box. So as this Mobility Express capable AP boots up, the first thing that happens is it boots up the AP operating system, or I'll refer to these oftentimes as the persona. So the AP persona or the controller persona. So when the AP boots up, it's first an AP, and so it boots up the AP image just like a non-Mobility Express AP boots up the AP image. And so it boots up as an AP, gets to the point where it starts up CapWAP, and you could log into it in the CLI if you wanted to. Once it boots up into the AP image, the next thing it's going to do is it's going to check to see if there is another master AP already on the VLAN. And if so, it'll probably just join up to it. It won't become the master controller. But if there's no other master controller, it's sort of the first Mobility Express capable AP to boot up on a VLAN, it's then going to trigger booting up the wireless LAN controller operating system or persona within that. And then we have these essentially two personas living in one box. We have an AP that can do all the normal AP functions, and we also have a wireless LAN controller that happens to use the AP hardware to do its job. And so that AP persona is going to join up to the controller running within itself, and then other APs can join up to the wireless LAN persona running in that Mobility Express capable AP. And so we have this master AP. It's the AP, it's an AP, but it's also a controller as well. And then any AP that joins up to the master AP, because we can have multiple different APs join up to this master controller, those are referred to as subordinate APs. So master AP and subordinate AP are the two types of terms we would use in this architecture. And this could be another 1852 in the lab. It could technically be a 3700 or 1600 in the lab, but we talked about it's most likely just going to be the other 1852 in the lab. But there's a fairly decent sized list of AP models that can join up to a Mobility Express master AP. And then they would become subordinate APs, even though they themselves couldn't ever become master APs if they can't run Mobility Express code. So more on that master AP. So again, to reiterate, it's an AP that also runs what is basically a virtual wireless LAN controller within it. So it's an AP that also runs controller software on top of that. Both personas, the AP persona and the controller persona, operate independently from each other. And so what that means is that the AP does have to discover and join up to the controller persona. Technically, that AP could join up somewhere else, although usually if it joins up somewhere else, it does that before it boots up the controller persona. But it has to discover and join up to the controller. And so the second the controller comes online, you don't see that it's joined itself. It takes, a short little bit of time for it to discover and join itself. So they are separate. They each have their own configs. So it's not like one master config for both the AP and controller. They are separated entities from each other. The controller is very much like a virtual wireless LAN controller. It has a management interface, just like any other controller that we have would do. The thing is, the controller's management interface will always be on the same subnet as the AP persona. And so normally when we configure this, it'll be a trunk port on a switch. And the trunk port would have a native VLAN. That's the VLAN where the AP pulls its IP address via DHCP. And that's also the VLAN that the management interface is going to be assigned to by default. And so the management interface is pretty much always untagged if you think about controller configuration terms. It'll be an untagged interface, and so it'll use the same VLAN as the AP's persona. Make sure that the IP address is configured as such, because we always do static IPs on a management interface, right? There's no DHCP there. So the AP persona will most likely use DHCP. The controller persona will most likely use static IPs for the management interface. Well, it has to use static IPs for the management interface. So once we have this master AP up and running, the controller portion of it has booted up and it's up and ready to accept APs to join it. Subordinate APs will discover and join that master AP just like any other controller that we've looked at up until this point. And so they need to learn about the management IP address of the master AP. They need to send it a discovery request. It sends it to discovery response, sends it a join request. It joins up, does all the normal join checks, regulatory domains and code versions and certificate types, all that type of stuff. Now the subordinate APs can be on any layer 3 subnet as long as it has connectivity to the master AP. So the subordinate APs, while they might be on the same VLAN as the master AP, and that's oftentimes the case, these are usually small deployments, and we're already on a VLAN that supports APs because it's an AP as well as a controller, right? So it's very common that the other APs might be on the same VLAN as well, which makes discovery very easy. We can just use the broadcast discovery method to find it. But there's nothing stopping you from having APs on many different subnets, all discovering the master AP as a controller and joining it up to it across layer 3 boundaries, as long as we have our routing up and running. One rule, though, with master AP, there can be only one master AP within a given VLAN. And if you do have multiple Mobility Express capable APs across multiple VLANs, they will actually all become master APs. You'll get one master AP in every VLAN that you have a Mobility Express capable AP. And so typically you would have all of your Mobility Express capable APs on the same VLAN so that you don't have multiple separate kind of Mobility Express deployments operating in the same airspace. So while the subordinate APs, no big deal to put them on different VLANs, the master APs or potentially backup master APs, they all have to be on the same VLAN in order to sort of build redundancy and not sort of step on each other's toes. But that's what will happen. If you have two Mobility Express capable APs on separate VLANs, they will both become master APs. So let's talk about the master AP redundancy. Since we are running within an AP, APs can go down. Maybe the switch that the AP was connected to goes down, the AP just fails itself, whatever the reason. So if the master AP goes down, we can have backups to that master AP, and then they can take over in the event that the master AP fails. They become the new master AP in its stead. So we get this redundancy by having more than one Mobility Express capable AP on the same VLAN, and that just automatically grants redundancy to the master AP role. So kind of on the back end, these Mobility Express capable APs will use Vrrp. It's a very similar solution to HSRP, which we talked about back in the network infrastructure series of videos. It's a first hop redundancy protocol, but it's using that to, according to documentation, both detect failure of the master AP and elect a new one. So they're talking to each other via Vrrp. It uses Vrrp group 1, and the only reason I mention that is that if you do use Vrrp in your network, you don't want to use group 1 for your switches on the same VLAN that you have these Mobility Express capable APs, because then they're all trying to sort of work together for Vrrp, and you might get some weird behaviors there. So fortunately for us, Vrrp is not in the blueprint. It's never been seen in the lab, so we probably don't need to worry about that, but it's a decent fact to know, I guess. All right, so how do we elect a master AP? So first of all, an election really only happens when there is no current master AP. If there's a current master AP, we won't just automatically have another more preferred AP come up and knock it off. While we can manually say, flip it over to a more preferred one, it's not a dynamic process in that respect. So if there are two Mobility Express capable APs on the same VLAN, one has already booted up the controller persona and is operating as the master AP, and then another AP comes up, even if it would potentially be a more preferred AP, there's not an election happening, and thus that other AP just would be a subordinate AP. It would join up to the master AP most likely, and it would just be waiting in the wings if we ever needed a failover event. But so if we have multiple APs come up kind of at the same time, and there's no current master AP elected, then an election happens. And so at this time we need to decide, okay, which one of these potential APs would actually become the master AP at this moment. And so the election has a number of different ways to determine who would win over the other. At the top, you can actually define a master AP, a preferred master AP. So you can say that this AP is the preferred AP. And so in the event of election, this is the one that would win it. In the absence of having an AP with that definition on it during the election, next is going to be Lease client load. Although at this point, it's usually not, it doesn't have any clients on it. This would be more, I think, if you had, let's say we had 3 APs that are all Mobility Express capable, the master AP and 2 subordinates. The master AP goes away, the 2 subordinates can then have an election with each other. Then they might actually have clients on them. But if they're all booting from scratch, there's no clients, hence lease load, client load really doesn't come into play in that scenario. And then the tiebreaker is whoever has the lowest MAC address. And so that's probably what will be kind of the default used in our labs as we're testing things out. Because we only have 2 Mobility Express capable APs. If they happen to boot at the same time, they won't have a client load. And so it'll either be user-defined master or it'll be lowest MAC address. In the lab, if they say this AP should always win the election, then we want to configure the user-defined master. Even if that AP happened to have the lowest MAC address, they're probably looking for you to configure the user-defined master, and so we'll look at that configuration as well. Now, once we do have a master AP and then another Mobility Express capable AP in the same VLAN, the controller configs are actually synced from the master AP to any other Mobility Express capable APs within the same VLAN. And that way, if the master goes away, the other AP can then detect the failure. It will then boot up the controller operating system or the controller persona within it using the config that it had synced from the master AP. And so it's impactful in that definitely all the APs that were joined to the previous master AP, their CAPWAP tunnels go down because they lose that access, and it takes time for that controller persona to boot up on the next master AP. And so APs will drop CAPWAP, they'll move into a standalone mode because these will all be Flex Connect mode APs. But then they'll rejoin up to the same IP address that they had before, because the config synced, part of the config would be the IP address of the management interface. And so they've already learned about that controller. And so they're going to either send a discovery request or join requests. Eventually, once that IP address becomes live again, it'll start responding, and it's not like they need to discover a different IP address or anything like that. So the same IP moves between the controllers, all the config moves between the controllers or the master APs. And so that's how we get our redundancy. But there will be a downtime. There's no HASSO in this type of a deployment. All right, so when we talk about building this Mobility Express architecture, here's the basics that we need to know how to do within our APs. We need to know how to switch an AP between being in CAPWAP mode as well as or being in Mobility Express mode. An AP that has Mobility Express code on it can be told to be either a regular AP, which would be CAPWAP mode, and if it's in CAPWAP mode, it will never be Mobility Express capable. It just boots up as a regular AP, tries to discover a controller, and joins a controller. It will never boot up that controller persona. Or we can say the AP is in Mobility Express mode, making it Mobility Express capable, allowing it to potentially become a master AP. And so at the beginning of your lab, There's no guarantees that your APs will be in Mobility Express mode. It might be in CapWap mode. It might not even have a Mobility Express image on it. So we'll look at the sub-bullet there, potentially download new code in the process. So maybe this AP has like a recovery image on it. But the recovery image has the commands to download the code, put it into Mobility Express mode, as well as if it already has the code in there, we might just need to flip it back and forth in the mode. So that's oftentimes one of the first things that we need to do. Make sure that the APs that need to be in Mobility Express mode are indeed in Mobility Express mode, and that might require downloading of code. Now, if this is a sort of a configuring from scratch scenario, usually once we put it in Mobility Express mode, one of the APs will boot up as the master AP, and we would have to do the initial controller config. Very similar to doing the initial controller config on a 5508, although in this scenario, not only do we have the CLI interface that we're pretty familiar with, and it's a variant of that, we actually have a GUI that we could leverage as well. I'll show you both. We're probably just going to use the CLI for simplicity's sake. There's really very little difference between the CLI and the GUI in terms of what you're allowed to configure in that initial setup. Potentially, we would then be asked to configure a preferred master AP, so one would win in an election over the other. And then if if the AP that should be the preferred AP didn't happen to win the election initially, we might force a failover so that that AP actually does take over as the master AP without having to just reboot everything and force an election. So let's work our way through these and show you how to make all these work. All right, so in my deployment, I have two Mobility Express, or APs that support Mobility Express. LAP2 is an 1852, just like we have in the lab. LAP4 happens to be an 1832, supports Mobility Express. The only difference really between these two is that LAP2 has 2 Ethernet NICs, LAP1 has 1. So, but Mobility Express can't take advantage of 2 NICs, so it's fairly irrelevant to us, so we can treat these the same here. But right now, both of these are actually in CapWap mode, meaning that they will never become master APs. And so we can see right now, it is currently trying to discover a controller. So it's looping. It doesn't know how to find a controller to join up to, and so it's just doing its normal AP type thing here. If we log in, default credentials of Cisco, just like a regular lightweight AP. We do get different CLI commands here. I think I've probably maybe showed you a little bit of that in the AirOS videos, but it's a different operating system underneath the hood. And so a lot of the commands are similar, but not all of them are. But if I want to do a show IP int brief, we see that it's pulled a DHCP address. So this is the, it's in AP mode, CapWap mode. It's pulled a DHCP address, it's trying to discover a controller. So this one's in VLAN 107, 10.0.7. LAP4, let's take a look at where this one is. Show IP int brief. It's in VLAN 108. So at the moment, they're in separate VLANs, and I'm doing this on purpose so I can show you both of them will become master APs. And on one, I'll show you the CLI setup, and on the other, I'll show you the GUI setup. But then we'll bring them into the same VLAN so that we can see sort of this redundancy aspect of things. Okay, so I'll start on LAP2. So the command to flip between CapWap and Mobility Express mode would be AP type, and then we can say CapWap or Mobility Express. How do you know what mode something is in currently, especially if there's already another master AP and you can't tell, well, is this a Mobility Express capable AP? It just doesn't happen to have it installed, or is it in CapWap mode and so it's never going to become a master AP? If you do a show version and scroll down to the part where it talks about what code level it's running, here we go. If it has a Mobility Express image on it, we see these extra 2 lines. So it does have this AP image type of Mobility Express image, meaning that I've installed the code that could support Mobility Express. But am I in Mobility Express mode or am I in CapWap mode? That's the second line here. Right now, it says not Mobility Express capable, meaning I'm in CapWap mode. And so I can deduce, do I have the appropriate image on there? And if so, am I in CapWeb mode or Mobility Express mode? If we don't see these two lines, then we do not have a Mobility Express capable code installed. And as a part of this process, we would also need to download the code. And if that's going to be a necessity in the lab, they would tell you, okay, there's a TFTP server at this IP address. Here's the name of the file that you would use to install, and I'll show you the way where you would put that in the command. So back to that AP type command. So AP type, we're almost always going to be putting things into Mobility Express mode, but if you said CapWeb, it would put it into CapWeb mode. It just so happens I'm already in that mode, so it just gives me a little message. But if it was in Mobility Express mode and then you said AP type CapWeb, it would reboot and then boot up in CapWeb mode. But we want Mobility Express mode. So AP type, Mobility Express. Now, the way that I'm set up, I have the code already pre-installed on my AP. And so all I need to do here is actually just hit enter. Because I have a Mobility Express capable code in here. AP type changed from CapWeb to Mobility Express. It's changed the mode to FlexConnect, and the AP is rebooting. Because one thing we'll see is the only AP mode supported in Mobility Express is CapWeb. Now, what if I needed to download code because I had some recovery image on it or something, who knows? It's the same beginning of the command, AP type Mobility Express, but then you would just type in the TFTP information. TFTP, : / the IP address of your TFTP server, file name .tar or whatever it is. I think it's a tar file. But they'll give you the file name, they'll give you the IP address, and so what it would do is reach out to this TFTP server, download and install the file name that you gave it. And so this implies that we have layer 3 connectivity from our AP to the TFTP server. Make sure that DHCP is doing its job. We could always, I don't know well, it's working anyways, even though I gave it a bogus file name there. But we can do static IPs, and the commands for that should be the same commands that we saw for static IPs back in the AirOS series of videos. So either you're already going to have the Mobility Express image on there, you just do the AP type Mobility Express, or you need to download it, and in that case you have the TFTP information at the end. If it has it, it'll just immediately reboot. If it needs to download it, it'll download it and then reboot. And then the next time it boots, again, we always boot into the AP persona first. But at that point, once the AP persona is booted up, which in this case it has, it's going to look, are there any other master APs currently on this VLAN? If there are, it won't become a master AP. If not, eventually it will boot up as a master AP. And so it's still checking at the moment, so it hasn't determined that I'm going to be the master AP yet. Okay, just pulled an IP address. Now that it has an IP address, it should be able to detect if there's potentially, I think, another master AP out there. See, LAP4 just finished its boot. It booted into, again, the AP persona. But I have a feeling that LAP2 will might start the master AP boot before LAP4 actually pulls its IP address. We'll see. But I guess it doesn't matter. They're on different VLANs, so they won't ever see each other for this perspective, because they only detects other master APs within the given VLAN, thanks to that Vrrp stuff. And so here we go. So now we see it's going to boot up the AirOS code. So this is the controller persona. Looks pretty much like a 5508 booting up, right? Seeing all the services starting up. LAP4 will eventually do the same thing. At the moment, there is no controller config from before because I've wiped everything out. And so what's the first thing that happens when you boot a freshly wiped controller? It's going to ask you to do the initial setup, right? And so once it's done booting up all the services, we're going to see that fairly familiar initial setup type script, just a few different types of questions than maybe we haven't seen on the 5508. Okay, so here's a note here, enabling controller provisioning. So the way that we actually get to the GUI is because it spins up a provisioning SSID. We connect to the SSID and get redirected to a provisioning GUI, but that's extra work. So let's just use the CLI here. So do I want to terminate auto install? Yes. What's the admin name? So they would have to give you all this information. Mine's admin with a password of ndojo123. What's the system name? This is the controller name because we're in the controller persona here. It has nothing to do with the AP's name, so I'll call it MEWLC, Mobility Express Controller. Country code, US every time. Do I want to configure Ntp Server? I'll just say no for now. Use the default Ntp servers, which are actually ntp.org servers. So I don't need those because I can't even talk to those in my network. I'll say no. I guess I didn't say that. I want no on Ntp server. Configure system time. Nope. I really should, but I'm not. Okay, what's the management interface? I'll use some. Again, it has to be on the same VLAN as the AP is, so 10.0.7 something. I'll say 22 with mask of /24 and a default gateway of 10.0.7.1. Do I want to configure a DHCP scope for the management interface? No, not right now. Do I want to create an employee network? This would be an SSID. I do not want to create an SSID in this. No guest net SSIDs. Enable RF parameter optimization. This allows you to set some initial RF wireless type settings based off of a couple of pre-canned templates that they have. I'm going to say no here. And then that's the end of it. So not as many questions as we're used to on a 5508. A couple of unique questions that we don't see on a 5508, but fairly easy to figure out what it is they're asking for most of this. So I like this, yes. I'm going to say yes. All right, at this point, it's going to reboot everything. So the whole AP, I believe, is going to reboot. AP boots up, and then the controller persona would boot up after that. Let's take a look at LEP4. So we'll use the GUI for this one, and we can see here that it even tells us, it creates this SSID called Cisco Air Provision. And hopefully you're the only one in your rack, or in all of the racks using this, because every rack would use this, and you know, how do you make sure you connect to yours? So hopefully no one else is using the racks and has an AP sitting at this prompt here. But let's take a look at this. So I'm going to go over to my client. Let's see. We have look for Cisco Air Provision. It should be an open SSID. I think it's an open SSID, or is it not? Don't actually see it. Let's network repair. Figured I would see it by now. Okay, sorry, it's not. It's not an open SSID. Cisco Air Provision. What's the password? Darn if I remember. It's either probably Cisco or password. I'll try Cisco. Password? All right, so it's password, all lowercase. Probably should have looked that up ahead of time. Okay, so it's serving its own DHCP. So I connect to it. It gives me a 192.168.1 address served from the AP itself. And then now all I need to do is try to go to a web page, and it should redirect me to the provisioning GUI.